Hi guys, here is the first set of classwork that we did, Understanding Limits classwork, dated 8/16/19. All right, so we've got some tables here. So we have an exponential function first, which is great because we were just talking about exponential, so we know they either look like this, they might look like this, they might be coming up like this if they get reflected, or down like that. But there could be an asymptote, like a horizontal asymptote. There are no vertical asymptotes for them. There shouldn't be any holes in an exponential function. It should be continuous. And that's kind of important because we're going to see rational functions are a little bit different. So if this is our function, and we see that, let's see, it's starting out negative, and it's coming up to a positive number, well, that tells me, first of all, it's going to be increasing. So it's not going to be one of these two decreasing ones, right? All right, and then if we look, say we start looking going left, so as x's are getting negative, are we getting closer and closer to some number or tanking really fast? Well, between -1 and -4, we just went down some, but between -4 and -7, we tanked a lot. So I think it's going to be this one here that's going down to -infinity, which means on the other side, we should be getting close to that asymptote, right? And that's true about this, as we get closer or further away from 0, and we start going towards infinity. Look at how close this number is getting to 3. So I think we have a horizontal asymptote at 3 here. So as x goes to -infinity, like I said, we're going down to -infinity. At -1, we have nothing special happening. We don't have any holes in the exponential function or something like that. So at -1, we're just going to be getting close to 1 from both sides, and it's just going to be 1. And at positive infinity, we're getting close to that asymptote. And what do you think that asymptote might be? I think I just said it. It's going to be 3. So exponential functions aren't too bad. Rational functions are a little bit harder to figure out, because what can we have with a rational function? Remember, they're the ones that have 2 pieces to them. They could have 3 pieces to them, something like that. Or maybe something like this, right? It's really making us pull up that pre-calculus to try to figure it out. But keep in mind, we've got asymptotes. That could be happening. Well, we definitely should have a horizontal. We could have a hole. Also remember, the asymptote just means that's where we're going to go as we get close to infinity. In the meantime, it could maybe go down beneath the asymptote and cross up like this. I don't know if you remember those from last year. But as we get close to infinity, it should get close to whatever that asymptote is. So for me, the easiest ones to figure out for a rational function are the -infinity and positive infinity. So going to -infinity, it's 0.998. Going to positive infinity, it's 1.002. So I think if I were to try to graph this, we've got that asymptote at 1. As I go to -infinity, we're getting closer to it from the underside. So we've got some sort of maybe like that happening. And as we go to positive infinity, we're getting closer to 1 from the top. But as we go to -infinity, we're getting close to 1. And our limit as we go to positive infinity is also 1. So those aren't bad. All right. And then if we look at our special places, by special I mean undefined. Remember, we have 2 different possibilities. It could be a hole, or it could be an asymptote. So what would it look like on either side of a hole? So remember from our limits, we talked about if there's a hole there, on either side, it should be coming to the same number, right? So if I look on either side of -2, look, those numbers are, well, in this case, they're identical. So we should have a hole happening here at -2, right? Whereas, although this isn't the shape of the graph, is it? But let's just pretend. There we go. Here's our asymptote we set up here at 1. What's happening at 1? Well, on the left side of 1, we're going down to -2,000. That's way down here somewhere. And on the right side of 1, we're going all the way up here to 1,000. So I think we've got an asymptote there. So this guy tanks down. And then remember, it's hitting 1 from the side. So I think it's doing something like that. So there's a basic shape of the graph if you can read all of that gibberish. So if I look at -2 from the left-hand side, where are we getting close to? Well, I think it's to this number here, which is 0.333, which is 1/3. And if I look at negative 2 from the right side, we're also getting close to that number, which we said was 1/3. All right. Do we have an overall limit there? Absolutely. The left-hand limit equals the right-hand limit. It's a real number, so our overall limit at negative 2 is 1/3. We can have an overall limit because it is a whole. All right, what about 1 from the left-hand side? Going from the left-hand side, we're getting close to negative infinity. It's taking there. And then if we look at 1 from the right-hand side, that's this piece. It's going up to positive infinity. Notice it's going to 2,000. That's way up there, considering it was at 1 not too long ago. All right. And so do we have an overall limit at 1? No. Left-hand limit is negative infinity. Right-hand limit is positive infinity. It does not exist. Even if these were both positive infinity, remember, it doesn't exist because we can't have a limit going to infinity unless we're talking about an infinite limit, like we were with the exponential. So if we're saying at 1, it can't go off to infinity. If we're saying at infinity, that's a different story, right? All right. See, that was all of them, right? Yep, we answered all of them. All right, I'm going to go ahead and pause. So this was just 1 and 2. Why don't you go ahead and pause your video here and try to figure these out, or come back and watch number 3 on the next video. I don't want these to run too long.